Hello mathematicians, this is lesson 8.4, more multiplication properties of exponents. So in 8.3 we did where it was 5 to the fourth times 5 to the second, and that would be 5 to the sixth. Now this is a little bit different. They're saying that 5 to the fourth is squared. So it looks different. It has 5 to the fourth in parentheses and then you square the whole thing. So really that means 5 to the fourth times 5 to the fourth, which if you did this, it would be 5 to the 8th power. So you're going to multiply these two numbers. So the same thing here, if you have an x to the second and then to the 5th power, it would be you times them and you'd get x to the 10th. So when it gets tricky is you'll see problems where they try to mix them both up. So they'll do this and then they'll do this. So you just have to know what to do for each instance. I personally like to write it out. I would write next to it, okay, 5 to the 4th times 5 to the 4th, that's 5 to the 8th, and then this is 5 to the 7th. So, simplifying a power raised to a power. So, instead of just writing it x to the 3rd times 6, you're going to write it as x to the 18th. This is the simplified version. So try both of these problems. Okay, so this first one is a to the 4th to the 7th. So I'm going to multiply them together and I'm going to get a to the 28th. Now this one, a to the negative 4th, would be written as 1 over a to the 4th, and then you're going to put it to the 7th power. So it would be 1 over a to the 28th. So simplify c to the 5th times c to the 3rd to the 2nd power. So notice, if you look on here, c to the 5th is completely separate. It's a completely separate thing. It stays c to the 5th the whole entire time. Nothing's happening to c to the 5th. Then if you look, c to the 3rd to the negative 2nd, everything is happening to that. So first you're going to multiply them together to get negative 6, and then you're going to add 5 and negative 6 to get c to the negative 1, and then you're just going to put that as a fraction. So try A and B. Okay, so this would be t to the 2nd times t to, and I'm going to multiply 7 times negative 2 to get negative 14. Now I'm going to combine these two to get t to the negative 12th. And then I'm going to do 1 over t to the 12th. And there's my answer. Here I'm going to do a to the 4th squared. So that's a to the 8th times a to the 2nd to the 5th, which is a to the 10th. And then I add these two together to get a to the 18th. Raising a product to a power. So, if you notice before, back here, they just did one thing to the power, t to the 7th to the negative 2nd. Now they're doing two things. It's a 3x to the 4th power. So it's kind of like the distributive property. You have to take that 4 and you have to distribute it to both things. So notice here, it's 3 to the 4th and x to the 4th. So you get 81 x to the 4th power. So it's distributing the power. So, which expression represents the area of the square? So, if I wanted the area of the square, I know area is one side squared. If the area was 4, it would be 4 squared, which is 4 times 4, which is 16. So I'm going to do 2x to the 4th, and I'm going to square it. Now, what happens is you have to square 2. 2 squared is 4. And x to the 4th to the 2nd is x to the 8th. So if you look here, that's exactly what they got. So try A and B in your notes. Okay, so 2z to the 4th. 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16, z to the 4th. Here I have 4 to the negative 2 times g to the negative 10th. So what I would do is I would do 4 to the negative 2 equals 1 over 4 squared g to the 10th, because both of them are negative exponents, so I'm putting them in the denominator. And then that equals 1 over 16g to the 10th power. So example 4 says, okay, now you're going to multiply two things together. So first you're going to do this one, and then you're going to do this one. If you notice what they're doing in the red, I love how the red like points out what they're doing. This one they didn't touch. Here they distributed the 4 to everything within those parentheses, because this one you didn't have to distribute because there was only one thing. It's just x. So they did this, and they got x to the negative 4, and then they did 3 to the 4th, x to the 4th, y to the 8th. So there's multiple steps that you have to do with each problem. So then what they did is they took the number and they put the number out front, because you're always going to want to have your numbers out front. So then what happened is they got 81, x to the negative 4th and x to the 4th cancel each other out, and then you get y to the 8th. So 81y to the 8th. So let's try A, and then you guys can do B and C and check. So c squared to the 3rd power is going to be c to the 6th times 3 to the 4th times c, so I'm distributing and putting the 4 with the 3 and the 4 with the 5. C to the 5th to the 4th is c to the 20th. So now you do 3 to the 4th power, which is 81. I'm going to put that out front so that gets canceled out. And then I have c to the 20th and c to the 6th, so that becomes c to the 26th. So try B and C, and then we'll correct. Okay, so I'm going to distribute. So I'm going to have 2 to the 5th, a to the 15th, times 3 to the 3rd, a to the 3rd, b to the 6th, because I multiplied those together. So now, 2 to the 5th is 32 times a to the 15th. 3 to the 3rd is 27. A to the 3rd, b to the 6th. So now I'm going to combine my numbers, 27 and 32. And that equals 864. And then a to the 15th, a to the 3rd is a to the 18th, b to the 6th. So you're taking everything you've learned in previous lessons and you're combining it. So now I have 6 to the 3rd, m to the 3rd, n to the 3rd. I'm distributing that 3. And then 5 squared, and then m to the negative 6. So 6 to the 3rd power is 216. M to the 3rd and m to the negative 6 is m to the negative 3 times n to the 3rd times 25. So 216 times 25, because 5 squared is 25, is 5,400. M to the negative 3rd, I'm going to put on the bottom of my fraction as m to the 3rd, because it's negative, it has to go on the denominator. And then n to the 3rd goes on the top. So then I have that. All right, real world problem. All objects, even resting ones, contain energy. A raisin has a mass of 10 to the negative 3 kilograms, so it's very small. The expression 10 to the negative 3 times the product of 3 times 10 to the 8th squared describes the amount of resting energy in joules the raisin contains. Simplify the expression. So really what you're doing, if you look here, is you're going to multiply 10 to the negative 3rd times this scientific notation. So what they did first is you have to do exponents. Well, 10 to the negative 3 doesn't have anything, so you have to distribute this first. So you're going to distribute the squared. So they did that right here, and they did 10 to the negative 3 times 3 squared times 10 to the 16th. And then they put the 3 squared by itself, and that's how they get this 9. and they combined the tens because those have the same power, the same base, and that becomes 10 to the 13th power. So it'd be 9 times 10 to the 13th. So let's try one. An hour of television use consumes 1.45 times 10 to the negative 1 kilowatt hours of electricity. Each kilowatt hour of electricity used is equivalent to 3.6 times 10 to the 6 joules of energy. Simplify the expression to find how many joules of television uses in 1 hour. So what you're going to do is you're going to multiply your base numbers, 1.45 times 3.6. So 1.45 times 3.6 is 5.22. And you're going to times that, and you're going to combine your tens. 10 to the negative 1 and 10 to the 6 is 10 to the 5th power. So if this, that is just your answer. It's that easy. You don't have to do really anything else. All right, that is it for your notes.